The question we are doing is from the year 2011. These are the questions which are asked in 2011 by giving 2 marks. Okay, these are the 2 marks question. Okay, all 2 marks question asked in 2011 we are going to do in this particular video. So let's start with the first question. First question is question number 14. That is, proof that root modulus of x whole square is equal to x square for any real number x. Okay, this question must be there in exercise 1.3. You can see, I think it is there in example or somewhere. Okay, so this question is from chapter number 1, must be around 1.3. So you'll find around that. Okay, so how to solve this question? Solution. Okay, since we know something, what do we know? Since modulus of AB, if you find the modulus of AB, you can write down this one as modulus of A into modulus of B. So we can do same thing here. Modulus of x, right, square. If you do modulus of x square means x into x, right? So I can write down this one as x into x, right? X square. Same thing AB, I can write down as modulus of A and modulus of B. Like this, I can write down x square as modulus of x and modulus of x. So I can write down this one as modulus of x into modulus of x whole square, right? Outside square. So this is equation number 1. Okay. Also we know something. We know x square is always positive. Also we know that, what do we know? We know that x square is greater than equal to 0. Okay. Also x square is greater than, because x square means positive number, right? X square is greater than equal to 0. Okay, for any x belongs to R, for any x belongs to real number. Okay, so we can write down modulus of x square. We can write down this one as x square. If you find square of any number or modulus, it will be positive number. It cannot be minus x square, right? Wait, let me write down. So let's say this one we can write down as 2 things. One is plus x square or minus x square. But since x square cannot be, like minus will not be there in x square, right? X square is greater than equal to 0, right? So we cannot, no need to write this one. We cannot write this one. So it will be only this one. So I'm writing down only this one. X square will be written down as x square. Modulus of x square is x square, right? This is equation number 2. Now from equation number 1, we know x modulus of x square is equal to modulus of x and outside square, right? So this one and this one are same here. Equation number 1 and 2, these are same. So equating equation number 1 and 2, we have, if you equate equation number 1 and 2, so this side are equal, so this side will be equal. So I can write down modulus of x square from here, which will be equal to this one, x square. Okay, and which is the question is asking. So hence proved. Okay, this was 2 mark question asked in 2011. Okay, let us do next question. Next question is question number 15. Question number 15 says, proof that in an AP with first term A, common difference D, the nth term of an AP is given by an equal to a plus n minus 1 D. 2 marks, 2011. Okay, solution. So here first term is equal to A, common difference is equal to D, the nth term is given by this much. So first term and common difference we know. So the AP, the given AP can be written as so the first term is A, right, comma, next term will be A plus 2D. This question is from chapter number 6, okay, for those who don't know. First term A, second is A plus 2D, third is, okay, second is A plus D, sorry. Second is A plus D, third is A plus 2D, and so on. Okay, so here A1, the first term A1 is equal to a, right? Which I can write down as a plus 1 minus 1 d. 1 minus 1 0, 0 into d. So this one will be a plus 1 minus 1 0, right? 0 into d. So a plus 0d, it is a, right? 0d, a plus 0, which will be a. So I can write down like this. Let me draft this one. Next, a2 will be equal to a plus. Now a2 is there, so instead of 1, write down 2 minus 1d. 2 minus 1, it is 2 minus 1, 1, right? So I can write down a plus d, right? 2 minus 1, it is 1, so a plus d, 1d, right? So I got second term. Third, you can write down like this again. A3, a of 3 will be equal to a plus 3 minus 1d, right? So a plus 3 minus 1, it will be a plus 3 minus 1, 2d. A plus 2d can be written down like this. Okay, so on. I can keep writing like this. I can keep writing like this, and it will be so on, right? So therefore, let me write down therefore. Wait, let me draw a line. So if you look at the pattern, looking at the pattern, we can write, a of n is equal to a plus, instead of a3 a plus 3 minus 1, a2 a plus 2 minus 1, so an will be a plus n minus 1d, right? So an is a plus n minus 1d, and we have proved, that's why hence proved, right? For any n, like for any n. Okay, fine, right? Hence proved n is equal to a plus n minus 1d, and this is how you are going to do. Okay, I hope you understood. If you don't, please do write in the comment below. Okay, I'll be there to help you. Okay, that's all. Thank you so much. Now let us do question number 16. Question number 16, form the quadratic equations whose roots are 3 plus root 5 and 3 minus root 5. So this is solution. We know that we can write what we can write, or we know that, let me write a, we know that quadratic equations can be written as quadratic equation can be written as x square minus sum of the roots x plus product of roots is equal to 0. Okay, so therefore let us find sum of the roots. So sum of the roots is equal to sum of the roots 3 plus root 5 and 3 minus root 5. 3 plus root 5 plus 3 minus root 5. Root 5 cancel. 3 plus 3 6. So let me write down 6 here. Therefore product of the roots it will be 3 plus root 5 into 3 minus root 5. A plus b, a minus b, so I can write down a square minus root 5 whole square. A plus b into a minus b, it is a square minus b square. Square and root cancel, it will be 3 to the 9 minus 5. 9 minus 5, it is 4. So therefore the required equation is x square, write down x square minus sum of the roots. Sum of the roots is 6, so write down 6x plus product of the roots is 4, so plus 4 equal to 0. And this is your answer. This question was asked in 2011 by giving 2 marks. Okay, so let us do next question. Next question, this question seems construction. Construct a pair of tangents to a circle from an external point. Traces of construction only. So this is from construction chapter. Okay, they are giving only 2 marks in 2011. So we need to draw only drawing portion we need to do. Okay, we don't need to write the steps of construction. So construct a pair of tangent to a circle from an external point. So let me take a circle. This is my circle. Now I need to draw a tangent to this circle from an external point. So let me define external. First draw a circle, second define an external point. Okay, let's say center of the circle, take center of the circle here. Okay, and this is the external point P, suppose, let's say. Okay, from where you are going to draw the tangent. Now join these two lines. Done with this, right? You have joined these two lines. Now what is the next step? Okay, I know I cannot use compass here. I don't find compass here, but let me see if I have compass. Spotlight magic here. So there is no compass with me, I think. Mesh to set square, protector is there, ruler is there, but there is no compass. So anyway, take this point from your compass. Okay, take this point. Okay, and take the radius of the compass little bit longer. Okay, little bit longer, make it little bit bigger radius of the compass, and cut here and downside also. Okay, take the same arc of the circle, arc of the compass, take this point and cut this 2 point. Okay, now you join these 2 points. Okay, you are bisecting the line. First you take any arc of the arc of the compass, take this point and cut here, take this point and cut the previous one, same thing do down here. Now join this one by dotted line. Let me join this one by dotted line. Okay, so this is a center point. Okay, I may be doing some mistake because I am doing by hand. So this is a center point. Now take this center point and this one as radius. Okay, let me name this as O, this is P, O, Q. Let's say P, Q, take this as radius of the compass and draw a circle. So if you draw a circle, your circle will be something. I need to make this bigger and draw a circle like this. Okay, taking PQ as the radius of the circle. Now we need to draw the tangent. So from P you draw a tangent. Okay, let me take not the dotted one, this one. Draw tangent like this from this point P to like this. Okay, so here PQO and PQR and S. So here PR and PS are pair of tangents. Tangents are the pair of tangents. So PS and PR are the tangents drawn to this circle. This is how you are going to draw. I hope you understood. If you don't, it was difficult for me to make you explain. You know, it was difficult for me to explain. So please forgive me, and any doubts please write in the comment below. So next question. In a right triangle ABC, right angle at B, so that cos square A plus sin square A is equal to 1. Okay, there are many ways you may have solved for this one. Okay, let me use one method and solve. Take this right triangle. This is a right triangle, right? So let me name this right triangle. Let's say this is A, this is B, and this is C. Okay, in a right triangle ABC, right angle at B, so that cos square A plus sin square A is equal to 1. So solution. So using Pythagoras theorem, we have, if you use Pythagoras theorem, we have AB square, this side square plus this side square is equal to this one square. So AB square plus BC square is equal to AC square, right? Now what shall we do? Divide both sides by AC square. If I divide both sides by B square, AB square divided by AC square plus BC square divided by AC square is equal to AC square divided by AC square. I am dividing both sides by AC square. AC square cancel, so this is 1. I can write down this one as AB by AC whole square plus BC by AC whole square is equal to 1. Right? AB by AC, BC by AC is equal to 1. We know, what do we know? Sine of A. If I take sine of A, it is opposite, that is BC by AC. So sine of A is BC by AC. Right? And cos of A. Cos of A can be written as BA, base AB by AC. So cos of A is equal to AB by AC. Right? So if I put this one here, instead of AB by AC, I can put cos AB by AC. So this is cos A. So square is there, so cos square A plus BC by AC. BC by AC is sine A. So this is sine square A is equal to 1. Okay, and this is what we have shown there. So hence shown. I hope you understood. I hope I haven't complicated anything. If you think I've done any mistake, please do write in the comment below. That's all. Thank you so much. We will meet in the next video.